Hello and welcome to video 8 in module 7. In this video, we'll be conducting a left-tailed hypothesis test. Now, I'm going to make the assumption that you've seen video 7, which is about a two-tailed test. So I'm not going to be going quite as slowly through the problem. It's not going to be super fast, but I'm going to make some assumptions so that I'm not like repeating myself all the time. So let's get started. Amelia wonders if families in Utica, New York are smaller than the typical American family. She surveys a simple random sample of 60 families in Utica and finds a mean of 3.04 people per family. According to 2014 census data, the mean number of people in an American family is 3.13. Assume that the population standard deviation is 1.78 people. Conduct a hypothesis test at the O5 level to determine if you can conclude that the mean number of family members in Utica is less than the American average. And we're going to round interim values to the nearest thousandth if needed. Okay, so to conduct a hypothesis test, we first must perform a check to make sure that we can actually do the hypothesis test. So we need to make sure that either the population is approximately normal, or that we have a large enough sample size. In this example, Amelia found an SRS of 60 families, so her N, her sample size, is going to be 60. Since this is more than 30, yes, we can indeed do a hypothesis test. For this example, we're next going to find the hypothesis test information, and we're going to collect the usual information. So what I recommend is that you take a moment or two and work through and see if you can write your summary of information. So read through that paragraph and pull out the information you need for the collecting part and for the hypothesis test part, and then we'll work through it together. So what I'd recommend to make this a little bit easier for you to work through, I'm going to put the answers on the next slide so that if you want to stop the slideshow here, you can. And then you can pick it up starting on the next slide. Okay, so let's check the results of our information here. On this problem, the hypothesis test information is a little bit tricky to find because it starts out with the sample information and gives you the population information afterwards. So to form the null hypothesis, it says, according to 2014 census data, the mean number of people in an American family was 3.13. This is the information about the population, so this is how we get our null hypothesis. Then, Amelia's suspicion isn't stated until basically, well, at the beginning it states, and also at the end. So you could use either of those as clues for your alternate hypothesis. So for example, at the end of the information, it says, conduct a hypothesis test to determine if you can conclude that the mean number of family members in Utica is less than the American average. So since we are investigating whether the mean is less, we're going to have mu is less than 3.13 people. You could also have used in the beginning where Amelia wonders if families are smaller than the typical American family. So the smaller than would also have been our clue that this is a less than problem. And then the alpha level that we're using if we scan the paragraph is 0.05. For the collection of usual information, mu is 3.13. It's the same as the null hypothesis. They told us that sigma was 1.78, so we have 1.78 people per household. The sample size we identified earlier was more than 30, it's 60, so we have 60 families. And Amelia's sample had a mean of 3.04 people, so X bar is 3.04 people. Also make sure you pay attention to the labeling of these values. So pretty much all of them are people or people per family. Alpha never gets a label, and N always has a different label because N is labeled with the who your subjects were. So in this case, we were studying families. Hopefully you did okay with summarizing the information. The places that tend to be the trickiest are identifying the appropriate mean and using that the appropriate values for the null and the alternate hypotheses. So remember that the number that you use in your null and your alternate hypothesis is always the same as mu. So you can use one to help you figure out the other. Now that we've got the summary, let's find some usual information. So we're going to find the standard error, the z-score, and the p-value. And again, I'm going to ask you to try this out on your own. So see if you can find the standard error, the z-score, and the p-value. And again, I've written the answers on the next slide. So if you want to exit out of the slideshow here and resume it on the next slide, you can do that. Okay, so here's how I found these values. I started with my standard error. My standard error formula is sigma over root n. So I'm going to take 1.78 and divide that by the square root of 60. And that gave me about a 0.23. So my sigma x bar was 0.23 people. For the z-score, I took x bar minus mu and divided that by the standard error. So I'm going to take the 3.04 and subtract 3.13 and divide that by 0.23. And when I rounded to the nearest hundredth, since it's a z-score, I got a negative 0.39. And lastly, for the p-value, I drew my curve of a negative 0.39. I shaded to the left because my alternate hypothesis was less than. If it had been greater than, I would have shaded to the right. And when I looked up negative 0.39 on the yellow table, on the standard normal table, I got a 0.3483. So that's going to be my p-value. Next, we need to draw a conclusion. To perform our analysis and conclusion, we need to compare the p-value versus alpha. So we're going to compare 0.3483 to the 0.05. Which of these values is larger? Is it the p-value or the alpha? In this case, 0.3483, that's like almost 35%. So this is more than a third of the time we would get a sample like this. So that's not weird, right? So the p-value is greater than alpha. And since it's not weird, that means it is not statistically significant. When it is not significantly different, that means we're going to fail to reject the null hypothesis, since the results are not statistically significant at the 0.05 level. Now, the conclusion that you draw when the results are not significant is more of a challenge to write. So when it is not statistically significant, remember, we can't prove the null hypothesis. We can only fail to reject the null hypothesis. We can't prove that all green teddy bears have a flower on them. We can just say that that might be true. So when you fail to reject the null hypothesis, it means that the null hypothesis wins, but we can't, proclaim it as definitive. So our conclusion here is going to be that families in Utica may not be smaller than the average American family. So our alternate hypothesis may not have been true. So we're going to have to use a little bit of wishy-washy language here. All right, that concludes this example for a left-tailed test. I decided not to make a video for the right-tailed test to give you a chance to try it out on your own. I do include a PDF next on the page that's going to have my solutions to the right-tailed example that you have. So work through that one on your own and then check the PDF that's included on Blackboard. And if you have questions on that one, we can go through that one together when we meet this week. Thanks for watching and have a great day.